Right, good evening, everyone. You're welcome to class. I hope you enjoyed your day. This is PED 144. That should be primary mathematics curriculum and methods. We started from looking at the brief history of mathematics and what mathematics is all about, and how to teach it to primary school pupils. In this unit, our concern is components of effective mathematics instruction. That's what we are concerned about in this unit. And of course, we'll be doing the following. Well, to start with, you should note that the unit is simply going to teach us how mathematics should be taught, especially taught effectively, and also how primary school pupils respond to, the teaching of primary mathematics. Um, we'll look at the following main content: effective kindergarten through grade 4 instruction, teaching primary 5 and beyond, then teaching through a concrete to representational to abstract sequence of instruction, using concrete manipulative to teach mathematics. Those are the things we will look at in this unit, where I pray we will have the time. Now, the main thing you should picture in your mind before we even start anything is that children should not just memorize mathematics. They should first understand it, practice it, see it. We should stop that idea of making mathematics abstract, like as if it's something of the mind, if something is, something you just imagine or something. Since you can't touch. When they say look for the root of square one or square two, you actually can't touch the root. So we shouldn't, because of that, say that pupils should only or merely memorize, mathematics. No, they should be able to understand it, practice it, see it, touch it, and draw mathematics. And even finally, they should be able to solve numbers and symbols. So the unit focuses on four major areas. One is effective mathematics, starting from kindergarten to primary 4. The other one is teaching from primary 5 upward, that is primary 5 to GS1, GS2, GS3. Then the concrete representational abstract sequence and the use of concrete manipulatives. This is one of the best, units we've been doing so far. Now, as a form of introduction to this unit, research has not produced one single method that can be called the perfect method of teaching mathematics. Instead, effective mathematics teaching requires the teacher to develop several abilities in learners. So let's take an example. For example, a child needs to understand mathematics ideas, remember facts, basic facts, follow mathematical procedures when solving some challenges in mathematics, then apply mathematics to everyday situations and probably solve word problems. There is this common one we use. You tell them if Sandra's mother, was a trader, and then she says apple, maybe she gave Sandra 10 apples in the morning, 5 apples in the afternoon, and then in the evening, 15 apples. How many apples did she give Sandra? That's word problem. The first thing to understand where you're coming from, deduct the mathematical ideas from the word problem before solving the word problem. So the importance of each ability changes the child, the child moves from lower primary to higher levels, and so on and so forth. Now let's take an illustration. If you are teaching a child 5 plus 3 is equals to 8, for example, we have different levels of understanding. When you say 5 plus 3 is equals to 8 in the primary 2 class, no, primary 2 is even higher. Let's say in a crèche, or maybe in a primary 1 or nursery 2 or wherever, in such a class, if you say 3 plus 5 is equals to 8. One child will look at it and the child will memorize 5 plus 3 is equals to 8. You understand? So when you say it, for instance, you say 3 plus 5 is equals to 8, and then the child memorize it and say 3 plus 5 is equals to 8. They memorize it. Maybe they keep mimicking you, they keep repeating after you until it sink into them, and then eventually they know it in their head that 3 plus 5 is equals to 8. But what happens when you give them 3 apples and so you call them, or you call the child, give the child 3 apples first, then call the child again and give the child another set of apples, maybe 5 apples. Then you ask the child, how many apples have I given you? It has now shifted from 3 plus 5. It is now real problem. So they should not just memorize 3 plus 5 is equals to 8 and not be able to relate to 3 plus 5 in the real world. So cramming it, memorizing it is good. But what if they now see that same thing they've memorized when they meet it real in real life? Will they be able to still solve it? That's how I would say they have to understand it, not just cram it or. So when you now ask the child to count the apples, if the child actually counts it, that means the child actually understands 3 plus 5, not just in the memory. The child can also relate to what 3 plus 5 is all about. So that's our introduction. Now let's go to objectives. What are the things we are to learn through this unit? Our focused objectives, I've simplified them here. One is, at the end of this unit, you should be able to do the following or explain the following. One, how mathematical concepts should be developed in pupils. After this class, you should be able to look at a child and develop, through professional teaching, the interest for mathematics in that child, or how mathematics should be taught. You should also be able to explain how to teach mathematics from concrete to representational to abstract. We have 3 things: concrete mathematics, representational mathematics, abstract math. Don't worry, they will look like Chinese for now, but when we start to explain, you understand what we're talking about. Then you should be able to explain how to use concrete objects, in mathematics teaching. And lastly, you should be able to differentiate or explain different types of manipulatives used in mathematics. We have different way we manipulate mathematical concept. Okay, let me not jump into that for now. Let's go gradually. Now let's go to the first thing we have here, which is 3.1, effective kindergarten through grade 4. Effective kindergarten, that means from kindergarten all through to primary 4. How to instruct them. That's what we want to talk about now. Now, for younger children, mathematics instruction should develop several important abilities. So in the material here, there are some abilities identified. So concept and reasoning is one. Automatic recall of numbers. Sorry, recall of number facts is another one. This is what I'm talking about now. Is another one. Then they talk about computational algorithm. They talk about functional mathematics. They talk about verbal problem solving. That's the one that contains word problem. Then, okay, those are the concepts that the material is trying to highlight. But what does each of them mean? Like, what is the meaning of concept and reasoning? What is automatic recall? What is computational algorithm? What is functional mathematics? What is verbal problem solving? So we'll look at each of them one by one for your perusal. Now, we'll start with the first one, concept and reasoning. You want to know how concept and reasoning contributes to effective kindergarten through grade 4 instruction. Now, concept and reasoning. Now, this means that the child must understand the idea behind mathematics. And what does that mean? When we say concept and reasoning means that the child must understand the idea behind mathematics. Okay, let's take for example, before you teach a child that 4 plus 3 is equal to 7, the child should understand what addition means. You know what we're trying to say now? You just wrote on the board 4 plus 3 is equal to 7, and you start asking them to repeat after you. 4 plus 3 is equal to 7. 4 plus 3 is equal to 7. What is the meaning of the symbol in between 3 and 4 that makes it 7? They need to understand what addition means. So if they don't have the idea of addition, if you write 4 plus 3 is equal to 7, by the time you write 2 plus 5, they will not know it. Why? Because they don't know what addition is doing there. They just know that you said they should repeat, they should repeat after you. You said 3 plus 4. You wrote 3. You wrote something that looked like the cross of Jesus in between. You wrote 4. You put the cross and you wrote 7. And so they don't know the meaning of that cross. So to them now, as you are telling them to repeat after you, they only believe that the only place where that cross is relevant is in between 3 and 4. So if they should put that cross in between any other figures, they will not know it. Why? You have not given them the ideas, the concept behind the equation you are teaching them. So they need to understand the concept. Now, the child that understand the addition concept of 4 plus 3 equals to 7, if you should put 4 pieces of sweet on the table and another 3 set, which is 3 pieces of sweet on that same table, and you ask the child to count them together and combine them using addition, the child will be able to answer you that we have total of 7 sweet on the table, which means you have just taught the child that addition means combining groups together. Combining groups together. Next time when the child sees addition playing a role in between some numbers that are different from 3 and 4, the child will still be able to answer it. Why? The child is not tied to just 3 plus 4 as a memory or memorization. The child really understands what addition is doing there. So that's what I'm trying to say on the first one, concept. Concept. Now, another example we can use to explain the first, effective way of teaching kindergarten through grade 4. Apart from, now, okay, still on that concept and reasoning, let's take another example to help you understand. If you want to teach them subtraction, for instance, now suppose we have maybe 5 apples on the table. Then you take away 2, it remains 3. So you write 5 minus 2 is equals to 3. So instead of merely writing 5 minus 2, the figures on the board, and telling them to repeat after you, 5 minus 2 is 3, 5 minus 2 is 3, you practically put 5 apples on the table, remove 2 and ask them to count the remaining. And then you use that concept to teach them what we call subtraction by telling them subtraction means taking away or finding what remains when something has been removed. Taking away or finding what is left when something has been removed. In that way, you have taught them subtraction. So that is what we are talking about. Then the material also talks about geometry. They give an example of geometry. So before you telling your pupils that a square has 4 equal sides, when you just come to, those children are very delicate. They practically don't know anything. So you just come to the classroom. Good morning, pupils. How are you? Hope you are fine. Today we are going to talk about geometry. Well, the first one we'll talk about is a square. A square has 4 equal sides. You are still talking in oblivion. They don't know what you're talking about. You are merely just, acting drama when you say that in their front. So they don't know what you're actually saying or what you're talking about. But instead of that, why not show them a square, an actual square, maybe a box? Show them a square. You can use the tiles on the floor that is in the classroom. You can use a cardboard to, create a square. You can use a piece of paper to do that and ask them to touch and compare each sides. Now you are taking them practically. Why? Because you want them to understand the concept. You want them to understand the concept, not just memorizing a square has four equal sides. And then when they actually see the square in real life, they will know that it's a square. No, 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 no. Let them understand the concept behind it, then it will sink. Now, the second, thing we'll talk about under effective way of teaching the kindergarten, and the kindergarten through primary 4 is what we call automatic recall of numbers, or number facts rather. Automatic recall of number facts. Excuse me. So we'll talk about automatic recall of number facts. What does this mean? Automatic recall means pupils should eventually know basic mathematical fact without having to count every time. They should know basic mathematical facts without having to count every time. What are we trying to say there? Now, let's take an example. If the first time you tell a child that 3 plus 4, or probably the first time you ask a child that what is 3 plus 4, there's a tendency that the child will start counting into our fingers. Count 3 on this side, count 4 on that side, try to count them together. But when the child has been asked over time, 3 plus 4, like the child has been meeting it time to time, 3 plus 4, and you've been counting and counting, it gets to a time that the child registers that in his or her brain. And without counting, the child will start telling you, 3 plus 4, that's 7. Why? There is automatic recall from frequency in solving that thing. As the child has been frequenting the solution of that problem, the problem becomes, naturally part of the child. So it becomes an automatic thing in the brain. The brain can automatically recall 3 plus 4 without counting. The child will tell you the answer is 7. Now, why is automatic recall important? Let's look at it. Why is it important? Imagine if you ask a primary 6 pupil, 347 times 8, or let's assume you met a primary 6 pupil, solving 347 times 8, for instance. Now, if the pupil spent 1 minute thinking, what is 7 times 8 again? Then it means the student will have problem in the larger calculations. You ask the child what is 347 times 8. Then the child is even starting to remember 7 times 8. Like 7 times 8 is no longer in the brain. Then the child will have a problem in the whole calculation. So the basic facts should become automatic in the brain of the child. Example, like 2 plus 2. A child doesn't need to start counting 2 plus 2. It should become automatic in the brain. When you say 5 plus 5, the child should know automatically that it's 10 without counting. So when you say 7 minus 3, without counting, the child should be able to recall without counting. These things are really things They are obvious things. When you want to do, let's say multiplication calculation that involves maybe thousands. Maybe I'm multiplying, let me not even go to thousands. Maybe I'm multiplying 317 by 3. You need to multiply individual component or item in that 317 by 3, which means there will be 3 times 7, there will be 3 times 1, there will be 3 times 3. So as I'm doing that calculation, when I get to 3 times 7, if I still need to go and be checking multiplication table to answer 3 times 7, something is wrong. So that's why you see that thing you do in primary school, when they come to class in the morning, the first thing they ask them to do is they have to recite multiplication table, maybe 1 to 15. They'll do it every morning. Why are people doing that? I believe you remember one of the classes we had on, I don't know, the PED now, that talks about, you know, when they continuously repeat the same thing over time. The main idea is to help them know it by heart without, consulting the book whenever they need it. So, important point to note is that a child should understand first before memorizing. Before automatic recall can come into space, a child must understand first before memorizing. So, from the course material, we can see that it's written here that pupils should not be expected to memorize addition facts when they do not yet understand what addition or the addition sign means. So, understanding first, then you practice, then you memorize. That is how it should work. It should not be memorizing first, then you hope that they will understand it later. No, that is wrong. You don't give them the memorization and then you leave the rest to God and say, God will allow them to understand it later. No, that's very wrong. Let them help them to understand first. Then they should practice that thing they understand. And then it becomes part of them in memory. Then the next thing mentioned there is computational algorithm. Computational algorithm. How do you teach effective kindergarten through primary 4 mathematics? The third one is computational algorithm. Now, what does this mean? Now, the word algorithm, when we talk about algorithm, the word algorithm can sound like we are coming from Germany when we are saying it. See, but it's actually simple. It's just a series of steps, used to solve a mathematical problem. Basically, we use it in programming a lot. When you have this problem, and then the solution to this problem involves you doing this, doing that, doing those, doing this, and doing that. So you now highlight the steps that it would require to solve the problem by saying, this is the first thing I will do, step one. After this step, the next thing I must do is this one. So this becomes step two. Then what the next one will do become step three, then followed by step 4, then step 5, and so on and so forth. So that is how it is. Now, let's take an example of computational algorithm. Example, if you have 2 digits addition, like you want to add 2 digits addition, like when I have, okay, I'm using Zoom. Let me try to write on the board. Kindly permit me to share my board now. I may need to stop sharing the screen so that I can share my board and write. So give me just 1 minute. Okay. Excuse me for that. No, I think I'll have to stop sharing first, then go to board. Yes. So I'll share my board very soon so that we can, of course, write. Just hold on while the board sharing. So I want to show you what it means for computational algorithm. When we say algorithm is step by step, series of steps used to solve a mathematical problem. That is what we call algorithm. Series of steps used to solve mathematical problem. Now, let's go to something very serious. Well, I'll call it something very serious, actually. Oh, my pen is not here. Okay, no problem. Let's write on the board. Mm. So, let's assume you want to teach your pupil, add 2-digit addition and This two-digit addition, I want to teach them. I want to teach them 28. Ah, no, that is too thick. Sorry. I need to reduce that. That's too thick. The thickness is too much. Okay. Assuming I want to teach my student 28. That's even too. That is my pen. I know to. Okay. I want to teach them 28 plus 17, for instance. Let's just assume that that is what I want to teach them. 28 plus 17. You know that there are steps you have to follow to solve this. You don't just jump. That is the first thing you have to do, followed by the second thing. So you have to teach the students that the first step is add the ones on this right side. That is 8 plus 7. Once you add them, you will get 15, which is 8. Oops, this is my 8. Where is it coming from? I think I'm already missing my pen. No. So, yeah, I think I know what is happening. The stroke is either too much. So, you have to teach them that 8 plus 7 is equals to 15. That is step one. Then step two is that, excuse me, they will write 5 and carry 1. So, step 3 will be to add the tens, which is 2 plus 1. 2 plus 1 will give us plus 3. But you remember you have to add the one you carry plus 1, which is to give us 4. So at the end, we have, excuse me, 45. Now, in solving this kind of mathematics problem, excuse me, we follow different procedures. We follow different procedures. Then those procedures are in series of steps. Step 1, add the unit. Step 2, since the units run into tens, carry the 10th value over. Add the 10th value, you get your total. Then the last step, combine the two together, and you get your final answer. So that is an example of algorithm, step-by-step instruction used in solving, excuse me, mathematical problem. Now let's continue. We have more things to do. Another example is when you want to do long division. When you want to do long division, you follow step by step by step until you get to the last one. That is an example of algorithm. Now the next thing is functional mathematics. They mentioned functional mathematics, and in functional mathematics, what we're actually trying to talk about is using mathematics in real life situation. So I will need to go back to share my screen now. I think we are done with the whiteboard for now. If we need it, we'll come back to it. So let's go back to the material and continue from there. So from the material, functional mathematics means using mathematics in real life situation. For example, you teach them maths to tell time. What's the time? They use mathematics to count money. You teach them maths so that they know how to measure. You teach them math in calculating change when they go to purchase anything. Those are functional mathematics. They are used for different functions. You teach them math, to compare prices when they go to Madam BC. BC. Madam BC says 500 now. We went to Madam Tayo. Madam Tayo said it's 350. So they know that Madam Tayo's one is cheaper than Madam BC's own. So they go to Madam Tayo's place to purchase that thing. They're using calendar. You teach them mathematics to use calendar. All those things are functional mathematics. So let's take a practical example of functional mathematics. Assuming a child goes to a shop with 1,000 naira and then he buys bread of 600 naira, pure water 100 naira, and ask how much change should he receive. By calculation, he's going to receive 300 because 1,000 minus 700 is actually 300. It's 300. So, functional mathematics is what helps uh, the child to understand real problems. Real problems. That is what we're trying to say. It helps the child to understand real problems, like real life situations. Okay, so what next? The next, effective way of teaching kindergarten through uh, primary 4 mathematics is, okay, excuse me, verbal problem solving. And I think that's like the last one. The number 5 is verbal problem solving. What does this mean? It means word problem in mathematics. We'll be making references to word problem. For example, you said maybe Amina has 12 oranges. She gives 5 to her friend. How many oranges remain? That is a word problem. That is a verbal problem solving. So the child needs to identify the following: what information is given, what operation is needed, how to calculate the answer. Those are the things the child needs to understand. What information is given? Amina has 12 oranges and she gave 5 to her friend. That is the information given. What operation is needed? The question says, how many oranges remain? And when we are talking about remain, we are talking about subtraction. So the operation needed is subtraction. Then how to calculate the answer? You do the subtraction of the information given and you get your 7 oranges remaining. So why mathematics must be taught step by step? That is another thing we need to see from this place. Why mathematics must be taught step by step. I think this is where it is. Why mathematics must be taught step by step. We'll look at it and then close the class. I think I've exhausted the time already. Now, mathematics builds on previous knowledge. You want to teach a child a new thing in maths. It's going to be easy when the child already have something already about the concept you want to teach. So you cannot successfully teach a child division when the pupil does not understand multiplication. The two go hands in hands. Multiplication goes, hands in hands. Especially when you're solving calculations that involves multiplication, you definitely will branch into division. That is what we're trying to say. So you cannot teach fractions now when the child don't understand division of the whole into part. So that's what we're trying to say. So mathematics teaching should be clear, systematic, and based on prerequisite skills. That is what we're trying to say. Now let's take a very simple illustration to portray that. Think of mathematics like a staircase, and the child needs to climb up. You start from counting, then length addition, then learns subtraction, then learns multiplication, learns division, learns fractions, and maybe finally learns algebra. So if the lower steps are weak, then climbing becomes difficult. If the child doesn't know how to count very well, by the time he gets to division or fraction, something will be wrong. He will always get zero. So the foundation needs to be strong. Another important thing stressed here is that mathematics needs to be practiced. So practice is very important. Now, understanding alone is not enough. Suppose a teacher teaches multiplication now, and say 2 times 4 is equal to 8, then the pupils understand. Then the teacher never allows them to practice it again. After 3 weeks, ask them what is 2 times 4, they will not know it again. So mathematics require practice. Practice makes perfect. So by in the next 3 weeks or after 3 weeks, that you ask them what is 2 times 4, you will get answers like, sir, I know it was something around 7 or 9, but they won't be able to say the correct answer. Why? Because you did not allow them to repeat and practice. So the material says that manipulatives can help children understand concept, but children may still need focused practice before basic facts become automatic. Another thing I would like to teach is mathematics learning difficulties. Not all children experience mathematical difficulties in the same way. So the course we are dealing with identifies several possible patterns in which pupils experience difficulties in mathematics. Mm, I think this class will need to stop here. So in the next class, I will try to give you those difficulties that I'm talking about from here, and then we can move on to something else. I believe this is a nice one. So you watch it and share it to your people. See you in the next class. Thank you for your attendance.